Hi, in this video we are going to introduce stack data structure. Stack is a linear data structure and it works like a box which is closed at one end, a box like this. So whatever you insert, you have to insert from this end, and whatever you remove, you have to remove from this end only. This end is closed. The insertion operation on a stack is called push operation, and the removal operation on a stack is called pop operation. So let's say we have initially empty stack, which is like a box closed at one end. When you insert an item 10, it goes like this. When you insert one more item 20, it goes on top of 10. When you insert one more item, it goes on top of 20. So this is how your stack looks like after doing 3 push operations. Pop operation also removes the items from the same end only. So whatever you are going to remove, it's going to remove from this end. So when you call pop on this stack, 30 is going to be removed. When you call pop on this stack, 20 is going to be removed. When you call pop on this stack, 10 is going to be removed. Now stack becomes empty, we can't remove any more items from this. Let us now see stack operations. Here are main 5 operations. IsEmpty operation tells you whether the stack is empty or not. It returns a boolean value. Push function, as we've discussed earlier, it adds an item to the stack. So if you have this stack and if you try to call push with every input, it's going to be inserted on top of 20. Pop function removes the top item. If you call pop on this stack, 20 is going to be taken out of the stack. Peek function simply gives you the top of the stack. If you call peek on this stack, you are going to get 20 as output. Size function tells you how many items are there in the stack. So if you call size on this stack, you are going to get the output as 3. Here is an example usage of stack. I have written some pseudo code here which is language independent. This line you may assume creates a stack. These 3 lines push 3 items into the stack. Print you may assume is a function that prints the item provided. So we have created an empty stack here. Then we are pushing 15, 20, 35. Then we are printing s.peek. Then we are doing s.pop. Then printing s.peek, s.size. And then pushing in item 5. Then peek. And then we are checking whether the stack is empty or not. Now please pause this video and try to guess the output of this print statement, this statement, this and this. What will these print statements print on the screen? Here I have written output of this program. Output of this program is 35, 10, 2, 5 and false. Let's see how did we get this output. We created an empty stack initially. So this is how our initial stack is. Then we pushed 3 items. So our stack becomes this. Then we called peek on the stack and peek is going to give you the top item. So you are going to get 35 as output, right? And please note that functions like peek, size, IsEmpty, they do not modify the stack. Push and pop are the only functions that modify the stack. So peek does not change the stack. Stack remains as it is, as it was earlier. Now when you call pop function, the top item is removed and your stack becomes this. Now when you call peek again, you are going to get the top of the stack, which is 20. When you call size on the stack, you have 2 items, so your size is 2. Now when you call push again, so 5 is going to be pushed on the top of the stack. Now when you call peek again, you get top of the stack as output. IsEmpty is going to return a boolean value, so it returns false here because stack is not empty. Now these function namings, they might be different in different programming languages. In C++ and Java, these functions are called push and pop only. There are containers, explicit containers for stack in both the languages. In C++, STL, there is a stack class. In Java collections, there is a stack class. In Python, there is no stack explicit container or collection. We implement stack either using a list or using a deck. So we can use list functions, and list functions are pop to remove the last item and append to add an item. So if you're using list implementation of stack instead of push, you can use append, and pop function is same in Python also. Let's now see the peek function. So peek function is called peek only in Java. In C++, STL, it's called top. In Python, you can get the top item by using -1 index, right? That gives you the last item from the list if you're using list implementation. Size function is same in C++ and Java. In Python, you have len function on list, so you can use the len function to figure out how many items are there in the stack. Push is same in C++, Java and different in Python. Peek, again, we have talked about. IsEmpty. So IsEmpty function is empty only in Java. It's empty in C++. In empty C++ STL, it's called empty on C++ STL container. In Python, there is no explicit stack class. So you can check whether a stack is empty or not in Python by using the standard syntax for list empty checking or not. So if you have a stack S, you can check if S. This is going to tell you whether the stack is empty or not. This is going to be true if a stack is not empty, and this is going to be true if a stack is empty, if not S, right? Using this syntax. There are other ways also in Python. You can check this way for empty stack also, whether the stack is empty or not, if you're using a list implementation. So in Python, there is no explicit container, but you can get all the functionalities by simply using a list. Let us now talk about two corner conditions on stack operations. So there is one condition called underflow. Underflow happens when you call peek or pop function on an empty stack. If you have a stack empty, and if you try to call pop, how can you pop an item from an empty stack? So you need to handle this error. When somebody makes a call of pop function, the pop function should handle this error. And different programming language libraries handle different way. For example, in C++, it is undefined to call a pop on an empty stack. Java throws an exception. Overflow is also a condition that happens when you try to push an item to a full stack. Overflow generally does not happen in library classes because they use dynamic sized arrays or linked lists. Dynamic size arrays grow automatically, like vector in C++, list in Python, or array list in Java. And if you are using a linked list implementation, then also overflow is unlikely to happen because you dynamically allocate new nodes and then you link them together. So these are counter conditions. Underflow is common, and when you are writing your own stack, you must handle it. Overflow is not very common if you use dynamic sized arrays or linked list implementation.